When we are looking into geography, first we have to look into cosmology and Earth, that is latitudes, longitudes. Then we go for geomorphology and climatology, oceanography and biogeography. First, geography means geo plus graphy. Geo means earth and graphy is nothing but a description. So a description of the earth is what we call as geography, and it is derived from the Greek. Right. Now what is geology? Geology is the study of interior of the earth. Now the father of geography has coined the term geography. Right. Father of geography is Eratosthenes. He has coined the term geography. We said geography means the description of the earth, and it is by the Greeks, geography and then Greeks. Right. Geography is the study of places and relationship between the people and the environment. Now we are going to look into the concepts related to earth first. When we see earth, it consists of oceans and continent. Now the North Pole to South Pole, the distance between North Pole to South Pole is 12,714 km, whereas the distance between the equator, distance between the equator is 12,756 kilometers. So the difference between north, south and equator is 42 kilometers. So how to remember this? We have to remember 12, 7 alone, right? Now we have 42 kilometers, right? So first for this 2, when 6 is separated from 4, we get 2, right? Then for 4 we have to have, when 5 is separated from 1, we have 4. So 1 2 7, 5 6 and 1 4. 42 kilometer is the difference between north, south and equator. So why we have to look into this difference? Because to check whether earth is a perfect square, perfect sphere or not. Right. So for circle, the distance of the radius is always diameter is always same for circle, right? Now but for earth, the diameter of north and south versus the equator is not same. So the equator is 56 and then 42 is the difference, right? So 1 2 42 127 127 12756 kilometer 127 14 kilometer, right? So we have 42 kilometer is the difference. So there is a bulge in the equator which is of 42 kilometers, right? There is a bulge in the equator, therefore the shape of the earth where we have a bulge is what we call it as the geoid. Geoid is the shape which is used to refer the bulge of the equator and the shape of the earth. Earth is flattened at the poles, so we can say the poles are flattened or the equator is bulge, so we call it as a geoidal bulge. Now earth is flat at the poles. This concept was first proposed by Newton. The rotation of the earth is very fast at the equator. Now let us take poles and then the equator, right? So this is the pole and then this is the equator. The earth has to rotate this pole and then this equator, right? Now this, for the rotation of this pole, this is pole, to rotate this pole earth has been provided 24 hours, but to rotate this equator earth has been provided the same 24 hours. So here the rotation will be slow and here the rotation will be fast, because to equator is very big compared to the pole, a small area to rotate. Therefore the rotational speed of the earth varies with respect to, see here, this area, to cover this area the rotational speed is different compared to this area. 1, 2, the rotational speed are different. Now we are going for the 3. Here even more higher rotational speed is required, but here you have a small rotational speed is enough, right? So the rotational speed is going to vary. This is what is the concept. So how do we tell that the earth is flattened at the poles? Because at the equator the rotational speed of the earth is very fast. Therefore when we stand here and hold a stone with a string and start to rotate, centrifugal force and centripetal force act in an object moving in circular motion or an object which is rotating. We have two kinds of forces. Centripetal is the one which is going to attract the object towards the center, and centrifugal is the force which repels the object to move away from the center. Now here, due to centrifugal force, bulging of the equator happens. Now, what is the reason for geoidal shape? The earth is flattened at the poles, that is why we got geoidal shape. Now who proposed this concept? Newton has proposed this concept, stating that the rotation of the earth is very fast because the centrifugal forces are acting from the center, bulged at the equator. Now the shape of the earth is geoid, or we can also call it as oblate sphere, right? So we can also call it as oblate sphere is the shape, spheroid is the shape of the earth. So we can describe the shape of the earth as geoid, or we can also describe the shape of the earth as oblate spheroid. Now what is this shape? It is a shape which is flattened at the poles and bulged at the equator. Geoid, due to continuous spinning, it is considered as a perfect sphere because the difference is less, right? So 42 km is the difference, therefore we are just considering it as a perfect sphere. Now the shape is oblate spheroid is the shape because the reasons are it is flattened at the poles and bulged at the equator. Now the proposal of the Newtons is all spinning bodies will have a flat pole and bulged equator. Now evidence that earth is a sphere. Circumnavigation. The first person to circumnavigate is traveling across the circumference of the earth. So when you start from here and you start traveling, you reach the same place. So you circumnavigated. The first person to circumnavigate is Ferdinand Magellan in 1519 to prove that Earth is sphere. Earth is spherical in shape. So the first person to circumnavigate is Ferdinand Magellan in 1519. So we also know other personalities like Vasco da Gama, right? Vasco da Gama is discovery of India. So Vasco da Gama is related to the discovery of India. From Europe to India is Vasco da Gama. Now circular horizon. What is meant by circular horizon? Horizon is the place where sky and then the land meets, is what we call it as a horizon. Now you are having a circular horizon, right? Now you have a straight horizon is when you are at a beach and at certain point you will see that the ocean and the sky meets. This is what we call it as the horizon. Now this horizon is a thin straight line, right, when you are at the base level and viewing the sea. But what is circular horizon? This is the second point. The first point is related to circumnavigation. Right, circumnavigation. The first person to circumnavigate is Ferdinand Magellan in 1519. Now we have Vasco da Gama is from Europe to India, right? Circular horizon is when you are standing at a pole and you watch, you see a circle, right? And you see here the sky and the land meets, but the area is in this shape. So a round area where the sky and then the land interacts when you are viewing from the top of a pole. So this is what we say it as a circular horizon. Now how does it define? Where the sky and the land meets is what we call it as a horizon, and a horizon is circular. From a taller tower, horizon is bigger, increased circular. If you are here, this is your horizon. If you go furthermore, this is your horizon. You see a circular area, right? This is the diagrams. The horizon appears circular when viewed from the high vantage point, and the horizon widens with the increase in the altitude. Ocean around fully water. Ships visibility is a third point, right? So when it is a flat earth, you can see all the ships which are visible. If it in a straight line, whatever ships are there, you can see the ships visible, right, through telescope, right? But you can only watch the some parts of the ship, right? When you are watching from here, you cannot even watch this part, right? You can watch only certain part of the ship, and as you move further, see, you could watch this ship here over here, but when you are over here, you couldn't watch the sail of the ship, right? Now this is what we saw. Earth is spherical in shape. Now we have seen three things. The first one is circumnavigation. The second one is you have to mention that it is a circular horizon, because here we have to give evidences for spherical in shape. We are not providing evidences for horizon where the sky meets the land. Next, the third evidence is the ship's visibility, right? Now, Bedford level experiment. When you are placing a pole of 5 km distance from one pole to another of same height, it should be the same height, right? But due to the bulge of the earth, see, these poles look shorter than this pole, right? So you have to adjust the height of the poles. This is what we call it as a Bedford leveling, right? Bedford level experiment. So far we have seen 4 topics. Those are circumnavigation, circular horizon, ship's visibility, Bedford level experiment. Sunrise and sunset. If it is a flat earth, sunrise must be of the same time in all places, but the sunrise is different at different places. For example, here you have sunrise, right? The remaining parts are night. Here you have midday. Here it is sunset. The sun is going to leave, right? Here you have sunset, right? So this is the example that if earth is flat, it happens at the same time. The sunrise, midday and sunset happens at the same time. But due to earth being spherical in shape, the sunrise, midday and sunset are at different times. Sunrise and sunset happens at different time in different locations. So it is happening at a different time in different locations. Now we also see eclipses. Eclipses is when the shadow of the earth, spherical, falls on the moon, right? This is what we call the eclipses. Eclipses is when the shadow, so we can see that the shadow is going to falls. When the shadow falls is what we call it as the eclipses. So when we have the lunar eclipses, sun, earth is in middle, and then we have the moon, right? The shadow of the earth is received on the moon. It falls on the moon. So we are describing about the shape of the earth. That is why we are using lunar eclipse. When we are describing sun, moon, and then we have the earth, is solar eclipse is when the shadow of the moon cast over the sun. But we are here discussing about the earth. That is why we have to mention the lunar eclipse, where the earth is in middle and the shadow of the earth is sun, earth, and then we have the moon. The shadow of the earth is reflective on the moon and it is spherical in shape. Now we have seen 5 topics, right? The first one is circumnavigation, and the second one is circular horizon. The third one is related to, let's look into, Bedford level experiment, whereas the fourth one is Bedford level experiment. The fourth one is sunrise and sunset. The fifth one is lunar eclipse, right? So circumnavigation, and then circular horizon, Bedford level experiment, sunrise and sunset, lunar eclipse. Yeah, this is the evidences for the earth being circular or spherical in shape. We have assumed it's spherical because the geoidal difference, the bulge is a small of 42 kilometers, right? So we have 6, 4, 5, 1, 127, 127. This is the equator and this is the poles. Now we are going to look into the topic of universe, right? Earth and the universe. Exploring the universe.